All right, it says we're recording, so that's a good thing. All right, so let me share my screen. We are going to, how do I share here? Here we go. All right, so we're going to go back to chapter 1 finally. So just real quick, the plan is, I think we'll cover chapter 1 today. This is really loose because I'm not used to teaching this on Monday, Wednesday, Friday as a summer course. So, but the basic plan is chapter 1 today, chapter 2. We may get into chapter 3 as well. We'll see on Wednesday. And then Friday, I'll have a review probably for about an hour is all. And then I'll let you out to take the test the rest of the time. So we will definitely have a test on Thursday. So, oh, by the way, did everybody, I should ask this really quick. I put up Friday, a proctorio. Right? Did I say Thursday or Friday? I meant Friday. Okay. Test is Friday. Because, yeah, you got to, that's a good thing to check with me because I'm not used to teaching this class as a Monday, Wednesday, Friday, especially during the summer. Did everybody take the proctorio quiz? And hopefully it was a one-question quiz. All it did was you've got to download the software, and did it work properly?
Oh, I haven't taken that yet. Do I need to take that now?
I got the software downloaded, but when I tried to access it yesterday, it was saying that access wasn't granted yet.
So this is so weird to me. That's like supposed to be a standard quiz, and I will create a new quiz. You need to download that software. If you've already downloaded it, theoretically it should work, but I don't know why that quiz isn't working. So I'm glad I did that because you need that software for Friday's test. And so, did it work for anybody?
So the only reason I couldn't take it was because I needed an access code.
No, if it's asking for an access code, either there's a problem with the quiz or there is, or it's not set up properly on your computer. So tell you what, just so you know, I'm going to create a new quiz. All it is, can you see this question? Hopefully everybody says yes, and then we will know that it's ready for Friday. So the weird thing is I did this quiz last semester, and both my college algebra classes, it worked fine, but for some reason my statistics class, it didn't work, which makes no sense to me. But is there anybody else for whom it worked? Well, that's not good. Okay, so I'm gonna delete that quiz. I'm gonna create a new quiz. It'll be due Wednesday, and it'll be just a one-question quiz to say, does this work, basically, or can you see this question? If it asks you for an access code, that theoretically means that you haven't downloaded the software. So anyway, I'm glad I checked that because I don't want to have any problems on Friday. All right. So we're going to talk about chapter 1, graphs, which is going to be graphing. Now, normally I try to do this with Microsoft Excel. I'm just going to warn you guys, because we just had so many problems with it last semester with the move into the online. We couldn't meet in class. I'm going to, I guess, I don't like this idea, but I guess I'm just going to make you guys hand draw your graphs, which doesn't sound fun to me, because nobody hand draws graphs, but it's what we're going to have to do. So, all right. So let's talk about statistics. Statistics is the science of data. It's often more art than data. How we define things affects our conclusions. And I can't remember if I told you this example. I may have. I'm just going to tell you again. I think I might have said this last week, but I used to work on a brain injury study, and I think I did tell you this one. I talked about the guy who fell out of the car, or out of the truck, the pickup truck, and fell on his head, right? Does that sound familiar? No? Okay, I'll tell you the story again. So I used to work on a brain injury study. We had all these hospitals across the United States and one in Canada. And we wanted to know how a person got their brain injury. So was it a fall? Was it a car accident? Was it a football injury? Was it a boating accident? You know, we had a big list of ways you could get a brain injury. So I got a call from our Atlanta office, or our Atlanta hospital, and she said, "Hey, I'm not sure how to categorize this injury." So what happened was the person was standing in the back of a pickup truck holding a mattress. The pickup truck crashed. The person fell out of the back of the pickup truck and fell and hit their head. So should I categorize that as a fall since they fell out of the truck, or should I categorize it as a motor vehicle accident since they were in the back of the truck? And I said, wow, that's a really good question. So I said, well, I'll check with the government. Obviously, the government will let me know. And the government disagrees with itself. So if you talk to the National Highway Transportation Safety Administration, because it involved a motor vehicle accident, they will say that it's a motor vehicle accident. If you talk to OSHA, they'll call it a workplace injury and they will call it a fall. So sometimes defining things is really hard, even as simple as that, because sometimes things fit into more than one category. So the idea is, in statistics, we define, collect, organize, and summarize and analyze our information to draw the conclusions. So the moral of the story is, you can define that any way you want, as long as you tell people how you defined it, and that works just fine. So we usually say how confident we are in our findings. Sometimes this gets left out in news reports. And so we'll talk more about confidence intervals, especially in a few weeks. So statistics has its own vocabulary, and we're going to discuss some terms. And the first one is, we're going to talk about individuals. Okay, these are objects defined by data. They could be people, or they could be things or objects. And then a variable is any characteristic of an individual. So a lot of times when you get data, it's set up in a table like this. And so this is just a quick table that I threw out here. And so let me throw it out here. I'm going to ask some questions here just to get a little participation, because I feel like I don't want you guys just falling asleep while I'm talking here. So we're going to go with Bridger in the middle. Bridger, what in this table here, what do you think would be the individuals? And if you're talking, Bridger, you're on mute because we can't hear you. Bridger, are you here? It looks like you're on mute. So I hope Bridger's not just showing up and walking away from his computer. Maybe we should have you be on camera. Okay, Allie, we'll go with you next. What do you think is the, what are the individuals in this data set?
It would be the people.
The people, right. Okay. It's nice when you get the first question, because usually you get the easy question. Elise, can you tell me what you think the variables are in this data set?
Yeah, it could be the something like music, athletics.
Okay, so that's one variable. The column heading there would be the major. Okay,
The
so that would be
major.
one variable. Okay, what would be another variable?
The points
The points would be a second variable. Are there any other variables?
and the grade.
And the grade. Perfect. Okay, so we've got three variables here. In this case, major, points, and grade. And then this first column here, these are the individuals. And in this case, we've got an eclectic class. Can you imagine being in a class with those people? So, all right. So remember now, individuals are objects defined by data. This is so much better if I'm in a regular class because I give away the answer when I share my screen. But let's say that researchers want to know who recycles. Let's say if you worked for the county government or whatever, you wouldn't know what each individual. So the individuals in this case, if you wanted to figure out that, the individuals would actually be a household of people, because generally a lot of us have blue garbage cans, and so we wouldn't know. So if Elise and I were in the same family, we wouldn't necessarily know how much Elise recycled versus how much I recycled. We would just group us all together as a family or a household, and so in this case, the individual would be a group of people or a household, and the variable might be the pounds of recyclables. Okay? All right, just to review again, I know we talked about this last week. The population is the entire group of individuals we want information on. The sample is a subset of the population, and we collect information to draw conclusions about the whole. So, some examples would be Gallup opinion polls. The variables would be the responsals. So the population for an opinion poll would generally be U.S. residents 18 and over, and the sample is usually going to ask 1,000 to 1,500 people, often by telephone. And so hopefully this is going to be a big part not only of this test, distinguishing between a sample and a population, but this is crucial to the rest of the semester. So make sure that you can identify that, because identifying the population for the sample is going to be important, especially the last few weeks of the class. All right, so one example is they have a thing called the current population survey. They actually sample 60,000 households each month, and they use that sample of 60,000 to estimate the population of 111 million Americans. Okay. All right, so some more terms that we talked a little bit about last time, but we need to make sure we continue to know. Parameter is the true value. It's usually unknown, and it applies to the population. So parameter and population, those P and P, those go together. Statistic is a numerical summary of data, and it applies to samples. So S and S, sample, statistic, P and P, parameter, and population. Okay, we talked a little bit about that last time, and so I just want to make sure we hammer that home. Those are some important things. We're going to talk about descriptive statistics. So these are where we describe general statistics such as age, weight, and the race of maybe a sample. Some other things that we might want to include on there are mean and standard deviation. Standard deviation or median would, and I know you don't know what a median is, and we'll describe some of these terms here later on. But those would be some examples of standard deviation or of descriptive statistics. So as I showed in here before, this is a table of data. Most experts prefer tables because it's harder to distort your data. Your table should be clearly labeled, and the source of the data should be labeled, such as the Census Bureau or however you got your information. All right, as we go back to this table here, you can see that these three variables we have, major, points, and grade, they are different types. So number one, points looks to be kind of a numerical variable, whereas major is a categorical variable. And then grade is kind of a hybrid of those. You can see that it's kind of a different category because these aren't actually numbers here. But of course, we all would prefer to get an A, which is better than a B, which is better than the C. So we have different types of variables that we're going to be talking about. So the idea with categorical variables, you can place an individual into group. Quantitative variables, we can use arithmetic operations. So I can see I'm going to have to update my notes here. So the idea here is when we have pie graphs and bar graphs, that's going to be used for categorical data. I usually do this. This is going to be hard for me because this is where I start to introduce Excel. So let me pull up some examples here. Even though I'm not going to teach you Excel, I think this is important to show you guys. Oh, why? Oops, I guess I shouldn't have done that. Yamala, did you want to take over my screen for some reason? I thought I was just allowing that person in the meeting, and I don't see that person in the meeting. That's weird. Anyway, all right. So I'm just going to open up a blank table here. It seems like I usually do a spreadsheet here, and what I'd like to do is pull up a spreadsheet if I can find it here. Hopefully this is the right one. Okay, perfect. Okay, so I think it's going to be easier for me to show you how to do this in Excel. You don't need to know how to do this in Excel. You just need to make sure you know how to make a graph. So let's say that a physical therapist wants to know the types of therapy required by a patient. And so the idea here is what we can do is this is kind of a summary table here, and we can so the therapist just says, okay, so we have a body part injured, and these are, so we've got a back injury, wrist injury, elbow, hip, shoulder, etc. So they just keep track of this. And so the idea here is this is a very simple type of table. It's called a frequency table. The idea here is we had 12 people that came in with a back injury, 2 people with a wrist injury, 1 with an elbow, 2 with a hip, etc., etc. Okay, so this is going to be an important term that we're going to need to know, and this is what we're going to call a frequency distribution. Now, a relative. Oh, am I not sharing my Excel sheet? Oh, it was probably because that thing. Thank you for letting me know. You guys can speak up, and you don't have to necessarily always do that. But I'm glad that popped up. Okay, now you can see my Excel sheet. Thank you. Thank you for letting me know you couldn't see. I think it was because Yamalo tried to take over my screen, and I let her do that, but I didn't mean to. Okay. So 12 people with a back injury, 2 people with a wrist injury, 1 elbow, 2 hips, etc. Okay, so this table here that we have with just basically with counts, that's what we're going to call a frequency distribution, okay? A relative frequency distribution would basically be the percent. So I'm going to ask somebody, how would you find the percent? And we're going to start with Wes. Do you know how to find the percent?
Yeah,
Take yourself off mute.
You create a cell right there in column C5 that says the sum of the numbers between B5 and B13 divided by B5.
Yeah, so we would need to get the total.
Vice versa, sorry.
Yeah, we're going to get the total first, but you were definitely on the right track. So, like I said, you don't need to know how to do this in Excel. I'm just going to do this quickly because I think it's easier for me to show you on Excel. But you will just add up those just with your calculator. So we've got 28 patients in this case, and then we will take, as Wes said, we're going to take 12. We're going to divide that by 28. Okay. And then oh man, I got a new computer and it's not working right. Oh, there we go. Okay, so basically the idea here is when you guys are creating a relative frequency table, basically you'll just take the 12 divided by the 28. Go ahead and leave it as a decimal. And so we can see here 42% of the patients are back, or of the injuries are back injuries, 7% are wrist, 3.5% are elbow, etc., etc. If I add this up, this should add up to 1 or 100%. And so what I've got here, the first two columns are a frequency distribution, basically just a count. And then columns 1 and columns 3 are what we would call a relative frequency distribution, okay? So relative frequency, that's just a fancy name for percent. Just go ahead and leave those as a decimal, okay? Now, another couple terms that I want to bring up here are cumulative frequency, okay? So, and then cumulative relative frequency. The idea here is, what I've got here are, I just want to add up everything above. So maybe I'm going to move here. I'm going to move this column here in the middle here. So basically, I'm just going to add up the category. So a cumulative frequency, I'm just going to add up the categories here. Now, when you've only got one category, these numbers are going to be the same. So I've got 12 and 12. With the wrist injuries, I'm going to add up the 2 plus the 12 to give me 14. So I've got 14 patients that had either a wrist or a back injury. I've got, if I add the 14 plus the 1, I've got 15 people with an elbow, wrist, or back injury. And I'm just going to add these up until I get to the bottom. When you add up all of the possible injuries, your grand total should equal the same number there. Okay? Excuse me, I don't know why I had that D on there for a second. But anyway, so the cumulative frequency says you're adding up all of the categories up to there. So 12 and 2 is 14, 12 and 2 and 1 is 15, 12 and 2 and 1 and 2 is 17, etc., etc. So this just gives you kind of a running total of the people that came to visit, in this case, a physical therapy clinic. So does anybody have any questions on that right now? Okay. Does it feel like you're finally in a statistics class after all the vocabulary we learned last week? Excuse me. All right. So, thank you. So the relative cumulative frequency, or the cumulative relative frequency works the same way. Instead of adding up just raw counts here, we're going to do the same thing with the percentage. So the first number is exactly the same. I've got 42% that are just back injuries. And if I do back and wrist injuries, 42 plus 7 works out to be an even 50%. And then I'm just going to copy that formula down. So of course, one of the nice things about Excel is you can copy these. You'll be doing this just with a calculator. But I've got 53% that are elbow, wrist, and back injuries. 60% are hip, elbow, wrist, and back injuries, etc., etc. And it should add up to 1 or 100% when you get to the bottom. So, do you all feel comfortable figuring out your frequency, cumulative frequency, relative frequency, and cumulative relative frequency? Okay, so this will definitely be a test question, and I'll give you probably a summary table, or I could just give you some raw data: back, wrist, elbow, back, hip, shoulder, hip, etc., back. I could give you just raw data like this, and then you would have to create your frequency table first. Obviously, that's the first thing you're going to want to do, is just get the summary of the table here and categorize that. So, any questions on that? Okay. Now, the question is, what kind of graph that should you create with this kind of data? So, would you say that this data is quantitative or categorical? So let's see. I asked Wes the last question, so this time I'm going to ask. Oh, there's Yami. Welcome, Yami. Can you tell me whether you think this data here, is it quantitative or categorical?
I kind of just joined, but I would say categorical.
Okay, that's a good guess. That's correct. Okay. All right, so these are categorical data. We've categorized the type of injury: groin, neck, hand, knee, shoulder, whatever it is. And so that is correct. Okay. So, what kind of a graph, since Yami answered that, Seth, can you tell me what kind of a graph you think? So the choices are line graph, bar graph, histogram, pie graph. That's probably all you would know at this point. What kind of graph do you think would be a good graph to create out of this data?
Either a bar graph or a histogram.
Okay, so bar graph or histogram, those are actually two different things, and we haven't talked about a histogram yet.
Yeah,
histogram is actually
is
the wrong answer. So a bar graph, you could create a bar graph out of this or a pie graph. Okay. Now, in this kind of a thing, to be honest, I would probably create a pie graph out of this. And I'll show you the difference. So here would be a pie graph that we might want to create. In Excel, these come up lickety-split. This would be a pain to draw by hand. I probably wouldn't give you so many categories, and hopefully they wouldn't be such thin slices. But you could draw either a pie graph or a bar graph. And I'll just draw these really quickly here. Now, one of the important things, and as I mentioned before, you do not need to know how to do this in Excel. If we were in a regular in-person class, I would make you do this in Excel. It's just a little bit harder to teach in an online environment, so I'm bagging that. But some important things for a bar graph, especially, this is something that students often forget, is you need to have what we call axis titles. So for example, down here on the bottom, we would put body part injured. And over here on the right side, we would put the number of patients. Okay. And then up at the top, we would probably put in a better title. These are visits to physical therapy office. Okay. So it'll probably be easier for you guys to draw a bar graph, so we could do that. But make sure when you do a bar graph, especially, that you are labeling your axes and also labeling your title here. So that's pretty easy. And then the nice thing about the pie graph is this are parts of a whole. So this kind of gives you, you can see here the vast majority are this big blue section, which are back injuries. And so that takes up almost half of the graph. And then the other half of the graph are much smaller injuries. Orange is a bigger one here. Orange, according to my little legend here, is the knee injury. So we had 4 knee injuries. So your biggest problem, if this was a company saying, what are our biggest safety issues? Well, the biggest safety issue is first back, and then knee would be second. Then we have this light blue here, shoulder would be the third one here. Now, one other thing that we could do, I'm going to put this on top of the pie graph for a second. And this is one of the other advantages to Excel, which you guys will have to sort this yourself. But what I could do is I could sort my data. And if I sorted it by the frequency, now you'll watch here, you can see what the graph looks like here, but watch when I sort this. One of the nice things about Excel is it sorts the graph as well. Oops, I shouldn't have done it. Well, I sorted that ascending. Let me try that again. Oh, except for it messed up all my values here. Data, sort. I'm just going to sort it descending, largest to smallest. And so this chart here, when it's sorted from largest to smallest, oops. This chart is now what we would call a Pareto chart, P-A-R-E-T-O chart, okay? And you can think of a Pareto chart as a bar chart in descending order, okay? Now, so basically the idea here is you can use a bar chart or a pie chart. I probably should put a better title on my pie chart. Visits to physical therapy office. Okay. Now that's a well-labeled chart. So when you have categorical data, you can always use a bar chart or a pie chart if it is parts of a whole. Okay. Now, oh, this is another good thing here. I was thinking of something else here, but you can also do a bar chart for 2 sets of data. Normally in my math classes, I say you can make a horizontal or a vertical bar chart. If we're comparing, I guess the first question is, let me ask somebody else this question here. Whose turn is it? Janae. Janae, would you say that this is categorical or quantitative data, this table here?
I would think categorical because they're in separate degrees or grades.
That's correct. Okay. So what kind of a chart would you create in this case?
I would do a vertical bar graph, but that's
Okay.
just me.
Yeah, you could either do vertical or horizontal. You probably wouldn't do a pie graph in this case, right? Because you'd kind of combine these. I guess you could if you separate the 1990 data from the 2006 data. But if you wanted to see them both, you could actually create a bar chart here, something like this. So the nice thing about this is you can compare 1990 in the blue versus the 2006 in the red. If I asked you to do something, I'd probably have to have you do colored pencils or something, or or you could create a legend so that you knew the difference with these. What would make this a better graph? I'll throw this out for anybody.
Labels on the axis.
Labels on the axes, correct.
Different title.
A different title. So we could say here, what would you put for the vertical to axis here? What do you think this data represents? I didn't really give you guys a good thing, but I bet you can figure it out.
Amount of individuals that reached that education level.
Yeah, so number of students. And then down here, we should make Easton answer all the questions.
Education
but it's
level.
Not voluntary. Yeah, education level. And hopefully this might be, I don't know what this data comes from, but we'll say these are Utah students or something. Okay. So that would be a vertical bar graph. We could do the same thing, and really it doesn't matter to me if you did it vertical, or you could also do a horizontal bar graph. Nice thing about this is sometimes it's a little easier to read horizontally. Now, once again, you don't need to know how to do this in Excel, but you should hopefully label these correctly, students. Okay. I would also need my axis titles. These are your number of students. If I can spell. And education level. Okay. So make sure as you're doing these that you are labeling these well. Okay. Now, one other thing that I just wanted to do, so let's pretend these are tax rates. Okay. Let's say that I had state, and I got Utah, Colorado, Wyoming, Idaho, Nevada, Arizona. And this would be the tax rate. And Utah is 6.75%, and Colorado 6%, and Wyoming's 4.5%, and Idaho is 6.25%, and Nevada is 3%, and Arizona is 4.75%. I'm just making this up. Okay. So, whose turn is it to ask questions? I think Easton. I was going to pick on Easton next. We're going to go to Bridger. We're going to give you another chance, Bridger. Remember, we do participation points here, so hopefully you're listening and you're not on mute. So take yourself off mute. Is this categorical or quantitative data? Okay. So Bridger, if you're not going to participate, you're not going to get full credit on these. Allie, let's go with you. What do you think? Is this quantitative or categorical data?
It's quantitative because there's percentages. Or wait, no, I don't know. How can you tell the difference? Because like it's like it has like the categories, but it also has numbers. So
Yeah, so that's a good question. Let's throw that out for everybody. What do you guys, should we vote?
Categorical.
Was that Wes that said that, categorical? What else do you guys think? Maybe
I would
can
say
put these
categorical too.
Yeah, so we're assigning, so the states, each of these states, you can think of these as a label for a state, right? So these are categorical. So there are going to be some, so yeah, this would be categorical data. We've categorized these states. Does that make sense, Allie?
yes, but what would be an example of like just quantitative? Like
We'll do that in a minute.
okay.
I want to finish out the categorical stuff, and then we'll go to quantitative. So so now that we've agreed that this is categorical data, what type of a graph should we pick?
Would it be a pie graph?
That's a good question. Now remember, so a pie graph, it is used for categorical data, but an important thing with a pie graph, it has to be parts of a whole. If these are tax rates, are these parts of a whole?
No.
No. Because if we added these up, they don't add up to 100%, do they? Okay. So this would be one case, and that's why I picked it, where it's categorical data, but you would not want to do a pie graph on it, because these rates, they aren't intended to be added up. Okay. So instead of a pie graph, what would be a better graph?
Bar graph.
Okay. All right. So if we did a bar graph on these, insert. Now we can do it either way. We'll do the horizontal. Oh, actually, I should mention something here. Even though you guys are not using Excel, okay, Excel has these really cool looking 3D graphs, but you would never ever do such a thing in my class, because I will mark you down if you do. The thing is about 3D graphs, they distort your data. You could even do a 3D pie graph, but you will never ever do that. So the nice thing is when you're doing this on paper, you only draw in 2D, but we don't want a pie graph. We want a bar graph in this case, okay? And so in this case, we've got the different states here. We could turn this into a Pareto chart. How would we turn it into a Pareto chart?
Anybody or
Yeah, we'll throw it to anybody.
put it in descending order?
Put it in descending order. So we'll do data. We'll sort it in descending. Oops, that's ascending order. Descending order. Okay. So now we can see in this graph, Utah has the highest rate, followed by Idaho, Colorado, Arizona, Wyoming, and Nevada. Okay. Of course, we will add our chart labels. These are the western states. And maybe this is sales tax. Maybe these are Rocky Mountain states or something. I think, yeah, we didn't pick California, so we'll say Rocky or something like that. Okay. All right. So any questions about categorical graphs, bar graphs, pie graphs, anything like that? Okay. All right. Let's move on. Let me go back to my notes here for a second. Okay, so quantitative, we're going to use arithmetic off things. Oh, I forgot to mention this. Of course, you'll never create a 3D graph. You can see that I will say I will mark it down for those. Pictograms should never be used. So let me just show you this really quickly here. If I can open up my we'll do a quick thing here. Pictograph. Okay, now, I don't know if we have any education majors in here, but these are really cute looking graphs here where we, this is something that a lot of times they do in elementary school. You can see January, we talk about apples sold, 1 apple versus 4 apples versus 2.5 apples or whatever. Or we've got smiley faces, donuts, the key, you could have a donut, two donuts or whatever. You will never ever do this in my class if you want full credit. These are very cute. A lot of times they can, but they often distort the data. And so USA Today graphs. USA Today loves to make these graphs such as this one here, where you've got the full number of meals, and they do silly things like this. There was one, oh, this is a perfect way. Okay, we got to make the graph look like it's a cast on a person's leg. So USA Today, very artsy, cutesy, but don't ever do anything like this. Oh, here's another one. We've got a pictograph, kind of a bar graph that looks like a girl wearing her shorts or whatever.
Did you see the? Can you go back to the one with the meals real quick?
Okay.
What kind of questions or bias do you think that would cause that literally 3% of the adult population doesn't eat anything ever?
What kind of bias?
Or is it because it says full meals, so they just feel they snack all day? Or I mean, I just wonder how the questions would have been written to be able to produce a result. I mean, obviously people have to eat.
Well, hunger can be a big problem, and if you're homeless, you don't have any money to buy food, so you just do not eat, or you're fishing stuff out of the garbage can. You know, you're dumpster diving, and so yeah, there's
this
probably
is on an everyday
people.
basis.
Well, per day, yeah. These are probably homeless people that are dumpster diving,
Gotcha.
so they're
Okay,
you know
makes sense.
just getting what's left over. So I mean, it can be terrible, but yeah. But you can see they've tried to make this look like a plate. And I mean, this one's not as bad as some other ones, but you know, the cutesy graph or the exercise girl or whatever. Oh, we've got a hockey player here. Whatever. So don't ever do that. A real statistician would never try to be artsy. This you can see this kind of weird looking graphing project. Oh, so they actually made this a project? Oh, wow, that's funny. I will tell you, I taught a math for elementary teachers, and I told them the same thing I told you guys. Don't ever make a pictograph, and they all got mad at me because they were like, oh, we want to be artsy. I don't care. I'm a mathematician. I'm not an artist. So, anyway, all right, so we talked about pictograms. Okay, now let's talk a little bit about line graphs. When should you use line graphs? So line graphs are used to indicate time, so changes in time. Now, one of the things that I will say, especially in Excel, it would be really easy, for example, to create a line graph out of this data. But this is not, so generally you're going to use, this would be an inappropriate use of a line graph. And if I unsorted that, I wonder if I can do that really quick. One more. I could insert a line graph here. So you can see that the line graph changes. Now, it's not like, so anyway, let me, so the kind of data that you would use for a line graph, let's say you had date, and you had milk prices. Okay, so let's go with January 2020. All right, we're gonna just fill this down. Okay, so we've got a bunch of dates here, and it was $1.96, and then it was $2.15, and $2.22, and $2.35, $2.55, $2.45, $2.37, $2.22, $2.11, $2.22, $2.35, $2.35, and $2.42. Okay, so you can see that this would be some. The idea here is we're trying to look for trends. So in this case, you could create a line graph because you're tracking milk prices over time. Okay, and so you can see here from January till about July, you can see there's a definite upward increase in price. Of course, we're going to put in our axis titles. Probably don't need one down here because that's pretty obvious that those are dates, but this would be price in, let's say, dollars. Okay, these are milk prices. That's a fine title. And so you can see we've got an upward trend from January to June here in prices. Then we've got a downward trend from June until October, and then in October to February, there's a general upward increase. So, so line graphs are used to track data over a time period. Okay, and so that's when you would use a line graph. Now, one of the other things, well, I guess it doesn't matter because I'm not teaching you guys Excel, but I could create those dollar signs and it changes my graph, which is kind of nice as well. Okay, so just review really quickly here. If you've got categorical data, you're going to use a pie graph or a bar graph. If you're trending over time, you're going to use a line graph. And watch those scales. Now, one of the things that I could do is I could distort this graph by changing. So you can see this. Let's see what happens if I change my minimum value to be, I guess, 175, let's say. Now you can see, just by changing the scale, now it looks like I've got this much more drastic steep curve here. And I've just made this look like a bunch of mountains. Whereas before it looked pretty flat. So a lot of times you can, just by changing the scale, you can really dramatically do something. Now, I want to show you a graph that was put out by Jason Chaffetz, who used to be our congressman from Utah. Abortion. Let's see here. Now, okay, I want you to look at this graph here, And I want you to tell me if this is a good graph or a bad graph. So I'm going to open it up to the whole class, and you can tell me what you think.
It'd be a bad graph because the lines are too straight, so it's probably not very realistic.
Okay, so the lines are really straight, which so it does, that's one thing. But there's something that's even more important than the lines being straight.
I'm looking at the dates. It goes from 2006. And then it increases very misleading in a way.
Okay. So I don't have a problem with the y-axis here. But what do you notice about the x-axis?
There's no label.
There's no label, and not only that, but look at the numbers, especially on the right side of the graph.
The numbers are way off with 327,000 of being above.
Yeah, 327,000. I know Jason might not be good at math, but I always thought 935,000 was a much larger number than 327,000. What do you think? Okay. Now, he actually used this in a congressional meeting. And so what the point he was saying was, look, cancer screenings have gone down at Planned Parenthood, abortions have gone up. Okay, if he had drawn this according to scale, it would now look like the graph on the right. Here, let me pick it again. This one here. Okay, this is what it should have looked like. Okay, abortions are basically flat, and cancer screenings have gone down. So on the one hand, looking at the original graph, yeah, cancer screenings have gone down, but abortions have not increased at this rate. They've basically remained flat. In fact, these are the two graphs side by side. But this is what the graph should have looked like in this case. Now, so this clearly is a case of a misleading graph. And in fact, I'm trying to remember what her name was, Cecily something. She noticed that right off the bat, because his point was, he was trying to be political, and he's like, why have abortions gone up and cancer screenings have gone down? And abortions, I guess, have gone up a little bit, but cancer screenings have really gone down. So the interesting thing is, there's actually a legitimate reason, which you wouldn't get just from looking at the graph, of why cancer screenings have gone down. So Planned Parenthood does a lot of screenings, especially for women. And the point is that between 2006 and 2013, the U.S. Medical Association, or American Medical Association, had actually said, we don't advise you to do breast screenings anymore, because what's happening is they were doing too many they were doing breast exams, and they were finding women with lumps, and then they were doing surgery thinking that these women had cancer, and really they didn't have cancer. And so Planned Parenthood was actually following the guidelines that said, you know what, we need to quit cutting women's breasts off because we're doing this unnecessarily. And so they actually reduced their cancer screening. So there was actually a legitimate reason, medical reason, why these decreased. Abortions have gone up very, very slightly. As a percentage, it's not very, it's really quite flat. So at any rate, watch those scales. There are, leave it to a politician to do this. I guess this is actually the real graph. That's what it should have looked like. So I guess it was probably around 2009 when they changed the screenings. But anyway, so scales are very important. if you change the scale, you can make something look like a mountain, when in reality, it was a much flatter graph in the first place. So a lot of times, especially on these sorts of graphs, it's often a good idea to start at 0. Now that's not always the case for all graphs, but for a graph of milk prices or gas prices or something like that, you probably should have a 0 in there so that you don't distort your data. All right. Now, histogram. Okay, let's talk a little bit about a histogram. Oh, I've already talked about all this stuff. That's funny. A histogram is similar to a bar chart, but the difference is the bars touch together. And actually, I should add up. So we're going to convert numerical data to categories, to numerical categories. Okay. It's similar to a bar graph, but this time the bars touch each other. And so in this case, you need to group the data yourself. Okay. Let's say, let me pull up another spreadsheet here. Hopefully that has some something good that I want to show you guys. Here we go. Okay, so let's say, for example, that you had some data here. I'm going to put all this in a single column. And I know you guys don't have Excel, and I'm not requiring you to do this, but I think this is going to be it's going to be visually a lot easier for me to show you in Excel. Okay, so we've got a bunch of data. Wendy's restaurant just collected the raw data. They wanted to know the number of customers every 15 minutes during the lunch hour. So they collected this over several days, you know, between the hours of, say, 11 a.m. and 2 p.m. They wanted to know how many customers came every 15 minutes, okay? So I guess you can see, I'll throw this at Allie since she asked this question. Can you see that this is clearly not categorical data? This is clearly quantitative data. Does that make sense, Allie?
Yeah.
Okay, so this is the idea. Okay, so I've just got a bunch of raw data here. I've got a bunch of data here. The first thing that I'm probably going to want to do is I'm going to want to sort the data. Okay. Now, so I sorted that. Now, the idea here is I want to create a histogram. And so with a histogram, the idea here is I want to find out if my data look like a bell curve. Okay, so in order to do that, I need to group. In fact, I'm gonna add these notes on here. In order to do that, I need to group the data in equal size groups. Okay. Now, because you can have as many groups as you want in real life, I'm not going to give you 100,000 pieces of data. Okay, I'm going to give you a small data set, something like this. And so for my class, I want you to use, say, 5 to 7 categories. Okay, the categories cannot overlap. So for example, I don't want to say 1 to 5. I don't want to have a group 1 to 5, and another group 5 to 10, and another group 10 to 15, because if I have a 5, does the 5 go in the first group or the second group? Or if I have a 10, does the 10 go in the second group or the third group? Okay. So the idea here is I don't want your categories to overlap. If I'm going to do groups like this, maybe I'll go 1 to 5, 6 to 10, 11 to 15, etc. And so then if I have a 5, I know where the 5 goes. Now, these numbers go from, let's look down here. So these only go up to 11, okay? So 1 to 11. So I've got, looks like I've got 40 pieces of data here, and they only go from 1 to 11. So these categories are much too large. So let's think about this. If I do 1s and 2s, let's see how many, or maybe if I go 1 to 3. 1 to 3, 4 to 6, 7 to 9. Now, I know my data only goes up to 11, but I'm still going to stop it at 12 because I want my categories to be equal size. Okay, so this would only have 4. That's kind of small. Let's go with 1s and 2s, 3s and 4s, 5s and 6s, 7s and 8s, 9s and 10s. And once again, I know I don't have any 12s, but I'm going to go 11 to 12 because it's important that these are equal size groups. Okay? So the idea here is I'm going to create my own so I'm going to create my own frequency distribution. Okay. Now, what's a frequency distribution? We talked about that earlier. Whose turn is it to ask a question to? It must be Elise. It must be your turn, I think. I can't remember whose turn it is. Elise, do you remember what a frequency distribution is?
It should be the total number divided by 1.
Nope. Let's go with Yami. Do you know what a frequency distribution is?
Is it the, like, how frequent the number shows up? For example, like 2 shows up very frequently, you would count them up and then put.
Yeah, it's a count them up. That's all it is. So we're going to count up the 1s and 2s. Now, one of the nice things about Excel, it counts for me. You can see right here. So I've got 7 1s and 2s, 3s and 4s. I have 5 of those. 5s and 6s. I've got here 18 of those. 7s and 8s. I've got 7 of those. 9s and 10s. I've just got 2, 2, and 1. Okay. So the idea with a histogram is we want to find out if your data looks like a bell curve. So if you were to graph this, now, I guess one other thing that I want to mention here is it looks like a bar chart, but the bars touch in a histogram. Okay. So the idea here is we're trying to see if our data look like, so these are number of customers, okay? So before we can create a histogram, we need to create a frequency distribution, which is basically you just count up the number in each category. So in this case, if I insert a bar graph, okay, so I've just created a bar graph, but I don't want a bar graph, I want a histogram. So I need to make the bars touch. Okay. So make sure when you're doing your histogram, these are our number of customers every 15 minutes. And this is the count. Okay. So this can get a little bit confusing because we're basically saying we had 1 to 2 customers. We had that happen 7 times. We had 3 to 4 customers. We had that happen 5 times. Okay. And then this is Wendy's restaurant lunch hour. Okay. So so this would be a histogram. Now, I know that Elise, sorry, she, I think, was really telling me what was a relative frequency distribution. Okay, so you gave that instead of a frequency distribution. Can you remind us what is the relative frequency distribution?
Yeah, so I said it was the total number divided by the first number, which is 7.
Right. So we need to get the total of this, which happens to be 40. And then we're going to take the 7, we're going to divide by the 40. So that gives us 0.175. I'm going to copy that down. Now, one thing that you can check, a good thing to check your answers with when you're doing something like this, a good way to check your answers to say, well, do all my decimals add up to the number 1? In this case, they do, and I did it correctly. Okay. Now, another thing that I should mention here, okay, so, and maybe I will put this as part of a title here. This is what we would call a frequency distribution. Okay? But really, we should probably be, rather than using the raw numbers, we should be using the percentages. So whenever you're doing a graph like this, you probably should use, in this case, the first and the third column. And I'm going to insert another bar graph, and then I'm going to turn it into a histogram. Of course, you'll be doing all this on paper, okay? So you can see in this case, if I give it the same title here, Wendy's restaurant lunch hours. This is what we would call a relative frequency histogram. Okay. So these are number of customers every 15 minutes. And then this is your percentage of percentage. Okay. So you can see that the shape is basically the same, but the main difference is I've changed the vertical scale. So these are percentages, whereas these are raw numbers. Okay. So so this is probably, out of these two graphs, the graph on the left would be the better looking one. So all right. So I know I've done a lot of talking, and what I'd like to do is I've got another data set, and in this case, I've got two. I'm going to put these all in the same column. So this is the 3-year rate of return on mutual funds. So these are basically percentages, and I would like to have someone, maybe I'll let you volunteer. How's that? Whoops. I want you to tell me how to create a histogram out of this data. So who wants to volunteer and tell me how to do this?
First, you need to take your data and put it in some sort of order, whether it be ascending or descending.
Okay.
Okay.
We'll sort the data. That was, let me make sure if I can recognize your voice. That was Wes.
Yes, sir.
Yay! Okay, I'm going to know you guys better by your voice than by your face. Okay, so we've got this sorted, which was really easy to do in Excel. I will try very hard, although no guarantees, to have you guys, I'll try to give you sorted data on your test, so that hopefully that won't be too bad. Okay, so what's the next step?
Divide them into equal categories.
Okay, so as we go here, we've got, this goes from 10 to about almost 24%. Okay, so in something like this, kind of as a guideline for a small data set like this, you should have 5 to 7 categories. So what would be your categories that you would create for your histogram?
Well, there's 14 distinct percentages in there between 10 and 24. So I would go ahead and use 7 data sets and do every 2%. So
Every 2%. Okay.
10 to 12, 12 to
return. Okay, so you said 10 to 12 and then 12 through 14. Those overlap though, right?
Oh yeah, sorry. So I guess it'd be well, since they're decimal places, you'd need to go ahead and you take that into consideration. So 12.0 and then 12.1 to 14.
So very good. You're on the right track. I would probably go 10 to 11.99.
Okay.
And then 12 to 13.99.
Okay.
Does that make sense?
Yep.
14 to 15.99. 16 to 17.99. 18 to 19.99. 20 to 21.99 and 22 to 23.99. Will that cover everything?
Yes.
Yes, it does. Okay. All right, so we've got our rate of return. We've got 7 categories here, or yeah, 7. And
now you need your frequency distribution.
You need your frequency distribution. And what is that again?
That's the count of those that fall inside the category.
Okay, so I'm going to let Excel count for me. I've got 6 here. And the 12s to the 14s. I've got 14 there. Oh, I forgot to mention something, but we'll do that in a minute. 14s, 14s and 15s. I've got 10 of those. 16 and 17s. I've got 4 of those. 18s and 19s. Don't have any 18s, but I've got 3 19s. 20s and 21s. 20 and I've got none of those. That's interesting. And 22s and 23s. So I've got 3 of those. Okay. All right. Now here I'll just, well, let's say that I want so I want you to create a relative frequency histogram. How would you do that?
Now you'd want to take your create your histogram chart, and you'd want your y-axis. Well, first you gotta create your percentages. Sorry.
Yeah, we gotta get our percentages. Okay, so I need to get my total. So if I add up my total here, 40 mutual funds in this case. And then how do I get the percentages?
Just divide that by your total.
Yep, 6 divided by 40 in every case, okay? So I'm going to copy that down. Okay, bang. Okay. So now we're going to use the first column and the third column.
Yep. And you'd use the percentage as your y-axis and the rate of frequency as your x-axis.
Okay. And of course, you guys will be doing this all by hand. But
That's a bummer. I really like Excel.
Oh, I do too, but some people hate it, and it gets pretty complicated in this class. And I just had I had a heck of a time with the tests, and so.
Gotcha.
Some people are going to be so happy that we're not using Excel, but in real life, you would never hand draw anything. But anyway, we're making do with the coronavirus here. Okay. So these are, what would you label these? I was going to tell you, but so since Wes has been answering all the questions, I'm going to have somebody else who wants to volunteer to answer these questions.
I can. So the label would be the...
Is that Easton?
Yeah.
Okay.
So for the title, I'd put 3-year rate of return on mutual funds.
3-year rate of return.
Or the relative frequency of the 3-year rate of return for mutual funds.
That's good enough. Okay.
And that would be the relative frequency?
Nope.
Or the percent relative frequency?
Okay, so this is interesting because we've got 2% here. Okay. We've got your percent of your rate of return, and then you have the percent of each fund.
Mm-hmm.
So this down here is not the relative frequency. This is your rate of return. Rate of return. Okay. And this is your, what is this?
Is that the percentage of?
Percent of funds in each group. Okay. So this is a little bit confusing, but basically we've got 15% of your funds return 10 to 12%. And you've got 35% of your funds reserved 12 to 14%. Does that make sense? 1/4 of your funds returned 14 to 16%. Okay. So anyway, now I mentioned this earlier and then I kind of forgot about it. The idea here is we want to see if our data look like a bell curve. So let me go back to this first, and we can use this for now. Would you guys say that this Wendy's restaurant lunch hours, does that look like a bell curve to you?
No.
Yeah, kind of maybe, but not really. Okay. Let's go with this one here. Does this look like a bell curve?
Okay. It did until we got out the very last variable, the 22 to 23.
Well, you could kind of see here, you can see that you've got a peak here at the 12 to 14% here. This is where your peak is. And you can see that the right tail is much, there's a lot more funds in the right tail than the left tail. The left tail's only got one group. This has got like 6 groups on the right. Okay. So this is what we would call a right skewed. Okay. Now, and in fact, let me just draw a few pictures here. Oh, I didn't mean to do that. Let's see here. And I'm going to make these smooth curves. When you're doing a histogram, they're always going to look a little boxy. But the idea here is, okay, this would be an example of a left skewed. Okay. This would be an example here of right skewed, it's K-E-W-E-D, okay? So this would be a right skewed histogram. This would be a left skewed histogram. Now, hopefully we hope our data, now our data is our data. If it's nice and symmetric here, like this, you could say that it's symmetric, or bell curve. Okay. So these are the types of histograms that we would look for. Okay. So another type of histogram that we might see is going to look very boxy, and in fact, here I'm going to draw a box here. Okay. This would be what we would call a uniform. Maybe I'll just type in here, uniform distribution. Okay. Another thing that you might see when you're making your histogram is something that has maybe two peaks. Something like this, okay? This would be what we would call a bimodal histogram. You could also see something like this. Maybe I should add this to my notes. Maybe it's got three peaks. 1, 2, 3, something like this. This would be what we would call trimodal histogram. Okay. And you could even see something that was not anything like this. But these are probably what I would say the 6 most common curves that you will see. So as we think about these here, you could maybe argue, so this is definitely right skewed. You could maybe argue that this is bimodal, because you've got two peaks here. You've got this peak here in the second group, and then you've got a kind of a peak here on the tail. You could argue that that was bimodal, but it's definitely right skewed. Definitely. If you go from the peak, the right tail is takes up much more space than the left tail does. Going back to this one, you could definitely argue that this was bimodal as well. You kind of got a peak here and a peak here. This one's roughly, you could argue it was roughly symmetric. I still wouldn't argue that it was bell curved. But yeah. Anyway. So one of the questions that I will ask you on your test after you've created your histogram, okay, is to describe it. And so the idea here is when you're describing it, these are the terms I'm looking for. Is it left skewed? Is it right skewed? Is it symmetric or bell curved? Is it a square, kind of a uniform distribution? Is it bimodal, trimodal? Okay. So so those are the terms I'm looking for. Now, I do want to mention, do I still have that other thing open here? Some people would look at this and they might say that it was skewed, okay? Skewed does not refer to line graphs. Line graphs, we're looking for trends. So you've got an upward trend here from January to June, a downward trend from June to October, and an upward trend from October to February. So don't say that this is a skewed, because skew only refers to histograms, okay? It doesn't refer to time data. And so remember, with a histogram, the idea here is you're converting numerical data into numerical categories. And so that's another important thing. You're still going to find your frequency distribution and your relative frequency distribution. You're just going to have to do that for quantitative data and making a histogram. So does that make sense? Does anybody have any questions on what we've talked about so far with histograms? Okay. What else are we talking about? I probably should add some of this stuff. This is why it's really good to come. Okay, so let's see. We've talked about Pareto chart, the histogram in descending order. We've talked about relative frequency distribution. Those are percent of observations. A frequency is a list of each category and the numbers of occurrences. Oh, a stem plot. That's another thing. I actually don't really like stem plots. I will show you. Where's my histograms? A stem plot or a stem and leaf plot. Okay. Now, like Wes, I would prefer that you guys would just create a graph and a histogram. So back before computers, it was kind of a pain to create these nice looking graphs here, these nice looking histograms. So you can think of so this is called a stem plot. It's also called a stem and leaf plot. So these are the same basic thing. And so the idea here is, as we look at this, let's say that I have a bunch of data here that represents gas mileage for 2008 sedans. And so I've got a bunch of models here. And let's say that I don't want to create a histogram because it's just too big of a pain. And I'm in a hurry and I just want to do this quickly. So you can think of a stem plot as a text histogram. Okay? And the idea here is, as we're looking at my data, so I've got a bunch of cars here, and I've got a bunch of the gas mileage here, okay? So this column here, this would be a quantitative column. These are basically a bunch of numbers, right? And so you can see here I've got 15 looks like it's the smallest. It looks like the highest I go up into the 30s, 32. And so what I can do is I can create a stem and then I can create leaves, okay? So as we look at this, the idea here is I've got a bunch of 10s, I got a bunch of 20s, and I got a bunch of 30s, okay? And so the idea here is as you're doing this, you're going to hand draw this, okay? And so you'll use the 10s digit, 10s, 20s, 30s as the stem, and then as the leaves, you will just add the things here. So the first number I have is 24. So I'm going to put 24. Okay. Sorry, I'm trying to make this a little bit smaller. Okay. So this number 24 represents 24 there. This number 15, I'm going to go 1, 5. Then I've got a 26. And I've got a 24. And I've got a 26. I'm going to resize these just so that they look closer here. I've got another 26. I've got a 30, so 30, 30. I've got a 31, a 31. I've got a 25. I've got a 23. I've got a 22. Oops, I'm putting these on the wrong place, aren't I?
Yep.
Let's try that again. Okay, where was I? So a 30, I got a 31, another 31. I've got a 25, a 23, a 22, a 31, and a 32. Okay. I'm going to resize these. Now, normally, so the idea here is, and I've kept this data kind of small, but basically I've got my stem. My stem is the tens digit. My leaves are the ones digit, okay? Now, as you look at this, if you turn your head sideways, you can say, does that look like a normal distribution? And so you can kind of see, well, if this is my peak, so tell me, do you think that this would be skewed? Is the data, or maybe I should say, are the data skewed? And if so, which direction? Okay. So if you turn your head sideways and you think of this as being your x-axis, and then these are on your y-axis, what do you guys think? Is this a symmetric distribution? Does it look like a uniform distribution? What do you think?
Right skewed?
Yeah, I would definitely go right skewed. Okay. You've got a much bigger tail on the right side than you do on the left side, because this clearly is your peak. Okay. So the nice thing about this is generally a stem and leaf plot you can do as a, you can think of it as a text histogram. It's a really quick and easy way to do this. And in real life, nobody ever does a stem and leaf plot. But back in the old days, when people didn't have computers, this was a really easy way. You could just take a pencil and paper and you could quickly draw this. In the book, they make a big deal about sorting this. It would be nice to sort it this way, but I don't care. Okay, so if you're just going along here, I don't care if your data are sorted, as long as you just make a stem and leaf plot. So just make sure you draw a line on the right side of your stem, and then all of your leaves you can do there. So does that make sense? Okay. I'll take that as a yes. Silence means you got it all. All right, wow. Okay, so center shape and spread, we're actually going to check for outliers later, but you're looking for the overall pattern. I will say this about a stem plot. Let me say this. Let's pretend that I had, I'm going to add one more car on here. Just move. Let's add a Ford Fiesta, let's say. And let's say it got 52 miles to the gallon. So make sure that if you have something like this, you might say, even though I don't have any 40s in here, I'm going to put that in here because now when I put, in fact, I need to add my line down here. Now when I add my Ford Fiesta on here, you can see this might be a potential outlier. This also makes this even more skewed, right? Perhaps you could argue that it's bimodal, although you might say, well, I don't know, that seems like it might be an outlier, just because it's so different than all the rest. But don't forget to put the 4 or the 40 here in this case, because if you just put the 52 right here, I'm going to put it there for a minute, it's hard to tell that that 52 is an outlier. Whereas if you had the 40 there, then you're like, wow, that seems like that's really distant from the rest of the group. So does that make sense? A lot of students will forget the 40 in this case, even though there's no 40s. So, all right, well, that was a long chapter. So do you guys have any questions for me then?
I do. The Excel spreadsheets are they going to be posted up in the note files inside Canvas or
With the lecture notes, do you want me to post them?
either that or at the end of class if you can go back to them so we can take either screenshots and put OneNotes or something like that.
I can put them there. That's fine. In fact, I think I'll probably add this to my lecture notes. I always talk about that. I don't have it in my lecture notes. I'm going to add this in here on histograms. Here, I'll add that in there, so that'll be part of my lecture notes. This is really out of order. Yeah, I can post those. I don't normally. Normally I make you guys do it in Excel, but I'm not going to make you guys do it this semester. That's still in the wrong place. Bar charts. Okay. Any other questions you guys have? All right. So so chapter 1 homework is going to be due on Wednesday, right before class. I will have a quiz that I'm going to write right now on chapter 1 that will also be due Wednesday, right before class. Wednesday we will cover chapter 2, maybe 3, and then Friday, what I think we'll probably do is I'll probably just spend about an hour doing a review, and I'll try to post the review Wednesday as well. Once I see how much of if we do chapter 3 or not, I'm not sure. I think chapters 2 and 3 will be a little faster, but I can't remember. But we'll have a review probably for about an hour on Friday, and then I will let you out, and then you can just take the test. I'll probably just give you a test that's about an hour long, and I will leave, and you guys can just take that. It's basically during our regular class time. So I still think we're missing a lot of people. I don't know where all these people are. I don't know if people have dropped. I'll have to check the roster here, but yeah, plan on a test on Friday for sure. We'll review for the first hour, and then the second hour, you guys can just take the test and post it, and I'll grade it over the weekend. So, oh, also one other thing, just to remind you, I'm going to erase that proctorio quiz that I had. I'm going to create a new proctorio quiz. It'll be a one-question quiz that just says, can you see this question? And if you can see it, you'll say yes, you'll get credit for it. And hopefully we will not have any glitches on Friday. Did everybody take classes spring semester? Is there anybody who did not take classes spring semester?
I did not.
You did not. Okay. So proctorial will be, well, actually, let me ask this question. For those of you who did take spring semester classes, did you have to use proctorial?
Yes.
Okay.
Not for me. I'm not familiar with the program.
Okay. Basically, just make sure when you open up the quiz on it, it's only going to be a one-question quiz. It should say click here to download the software. I will tell you this. It requires Google Chrome. You cannot take the test in any other browser other than Google Chrome. So no Safari, no Internet Explorer, no Firefox. It's got to be Google Chrome. It shouldn't ask you for an access code. If it does ask you for an access code, that means it's not installed correctly. So please, in fact, I'm going to do that right after class today. If you can take the proctorial quiz, the one-question quiz, can you see this question? Then that'll be good. But you will need a web camera. As far as the test goes on Friday, get 2 or 3 sheets of paper. Make sure that you label your questions. Basically, it's going to video record you. I can see if you're cheating or whatever. And then you'll hold up your paper, pretend this is my test. This is a bill, but so pretend this is my test. There's page 1, here's page 2, here's page 3, etc. And then I'll be able to check and see if something doesn't match. When you're doing your problems, please, if you can scan it in, that would be the best. But if you want to take a picture with your cell phone and email it to me, I would prefer that you save it as a Word document or a PDF. That would make my life so much easier. But if you need to submit it in 5 different files, I won't like it, but I will look at it. But if you can just paste it in a Word document, make sure it's legible. Some of you have really bad phones and it's really out of focus, and if I can't tell what you're doing, I can't give you credit. But it's going to be a combination of multiple choice and show your work. So if I say graph this, obviously I'm going to look at your paper and I'll see if you can graph it properly. So does that make sense?
Will this be something that we'll need to print off, or will we be putting it on our own paper?
You cannot print the exam, because if you do, Proctorio will kick you out.
Oh, okay.
So don't even attempt to print the exam.
I'm glad I asked.
Yes. I didn't know that the first time I did that, and it kicked some people out, and it was awful. So yeah, don't try to print the exam at all. Just put number 1, answer A, 2, B, 3. This is my graph. Whatever. Explain. If it says explain it. So these are a pain in the butt to grade, I'll tell you that. I wish I could make it all multiple choice, but the multiple choice is easy to grade because the computer can do that. And so there will be some on there, but I'm going to have to manually grade, because I'm going to tell you, I'm going to ask you to create a frequency histogram, a relative frequency table, and or histogram or a bar graph or whatever. Or I'll say, here's some data, create the graph that you think is best, and then you'll need to do that. So, any other questions? All right, so I'm going to create that quiz right now. It should be up in a few minutes, and if you can test that out and download the Proctorio plugin on Chrome, and we'll see you all on Wednesday.
Thank you.
Yep, thanks. We'll see you.